Hello. Today we will introduce Python. To get started, you need an integrated development environment such as Thonny. So that's what I'm using here. You can download Thonny by going to thonny.org, thonny.org, and then you can download it by just, if you're on Windows, you can click this first link, Mac, first link here, and Linux, there are several options here. I'm using it on Linux, but it works similarly throughout many different operating systems. So to get started, you might notice that, so once you've downloaded Thonny and installed it, you can take a look at some of the options here. So yours might look a little different than mine. You can go into Thonny options there in the tools menu, and from there you can go, for instance, to theme and font. I've chosen a dark background, but you can use whatever you like. And I'm using a large font here to show up a little better on the video. There are many other options in Thonny. And of course, you're welcome to use your own IDE, Integrated Development Environment. But Thonny is a really good one to get started with. So that's what I'm going to use for these examples. So in Python, you've got two different ways to enter data. And the one we'll look at first is the one called the interpreter. Here it starts, so it looks for somewhere within Thonny or whatever your IDE is, where you've got three arrows there. So to get started, we can use it just in kind of a simple way, such as a calculator, for instance. So in the interpreter, I can just enter something like 3 plus 5. I get 8. Okay, things are working, right? If I want to use an exponent, for instance, if I want to do, in many languages, if I want to do 2 exponent 3, I would use a little caret symbol, but not in Python. Python uses double star here, so something like this. If we want to do something more complicated, like let's say I want to know what pi is, I've got a little bit of a trouble here. So I try to type in pi. Python doesn't inherently know what pi is, and I get here an error. The assistant has popped up and said, name error, pi is not defined. Python doesn't know what pi stands for. Okay, so I can close this assistant out, but that means in order to get some of these functions in, I need to import them. So pi can be known to Python by using a library. And the one that we'll use for this is called math. So I'll do something like from math, import pi. And this will bring in from the math library or package, we'll bring in the variable pi. And now Python knows what pi is out to quite a few decimal places. So that's pretty good. If I want to do something like sine of pi, well, sine isn't incorporated in yet, so I need to do something. I need to retype from math, import, and then sine. But I don't like retyping, so I will hit the up arrow to cycle back through my previous commands. So I can do that by just hitting the up and down arrows on my keyboard there. So I can import sine, and now, with both sine and pi imported, I can type sine of pi. Now, sine of pi, you might know in mathematics, is equal to 0. But what we're getting here is 1.2246 something something e minus 16. So the e minus 16 part, let's understand what that is. That means times 10 to the power of negative 16. So this is a very small number. So this is almost equal to 0, excuse me. This is it's equal to 0 up to the first say 15 decimal places, and then after that we get a 1, 2, 2, 4, right? We get this floating point number, and that has to do with the mathematics of floating point numbers, which is fascinating. I encourage you to look into it. But for now, what we need to understand is that this thing is what's called machine epsilon, or close to machine epsilon. That is machine precision. This is, for our purposes, as close to 0 as Python is going to get in some circumstances. Okay, so long as we are, so if I'm later needing to check inside of a program if a number is 0, maybe I should check not if the number is exactly equal to 0, but if the number is very small, say smaller than 10 to the minus 15, for instance. would be one way to check if a number is 0. But we're getting ahead of ourselves a little bit. Okay, I'm going to hit Control-L to clean up the command line there a little bit, just to kind of start fresh. Okay, so that's just using Python as a calculator. Let's use it now to assign some variables. So I can do something like x is equal to 5. And if I ask it what x is by just hitting x and then enter, I'm hitting enter after each of these commands, it tells me that x is 5. Another way to do that, which is pretty common, is to print that variable. So print parentheses x, and I get 5 here. By the way, older versions of Python, you would write something like this, print x. In this case, that gives you an error. We're using Python version 3 or higher here, so the latest versions use print parentheses x, which is pretty standard by now. Okay, so we have x is equal to 5, and if I clear that command line, Python still knows what x is. But if I ask it, for instance, what y is, well, we haven't told it what y is, so I'm going to get a bit of an error there. All right, but next I would like to change x. So I could do something like x is equal to 7, and then that would, of course, change the value of x. But if I did something like x is equal to x plus 2, then if you haven't seen programming language before, this might seem a little bit funny. First of all, mathematically, this doesn't make a lot of sense, because if I interpret this as a mathematical statement, I could subtract x from both sides. I would get 0 on the left and 2 on the right. 0 does not equal 2, so mathematically, this does not make sense. However, in Python, it's done a little bit differently. What is happening is that the right-hand side is evaluated at using the present value of x. So x is currently set to 7. So here we've got 7 plus 2. That's evaluated first, and then it's stored in the left-hand side. So the result should be 9. And if we say print x, sure enough, we find out the value of x is just 9. We can see this a slightly different way if we go up to View, and then we go down to the Variables part of the menu. We can see some of the things that Python is keeping in its memory right now. So it knows what pi is, it knows what sine is, and it's got x currently set to 9. If I repeat this command, then x should now use the new value, which is 9. So x plus 2 should give us 11, and we can see it there showing up x is 11. All right. Or, of course, we could make it output here in the command line. There are other ways to do this. So a similar way is this operation is so common to increase a value by increase a number by a certain value and store it back in that number that you can do it a different way. So the command there is plus equals. So if I say x plus equals 2, then I'm going to add 2 to x. And if we take a look, x has been set to 13 there. So this is just another way. This x equals x plus 2 and x plus equals 2 are effectively doing the same thing. We could do something maybe a little bit more interesting. If I did something like x times equals, so the times is star, times equals 2, then this will multiply the current value of x by 2. Let's take a look at that. X is 26, right? And there are a lot of different variations you can use with this. This is especially useful in scientific computing. If I have, for instance, some initial time, and maybe I have some small time step like 0.01 or something, then to update the time, quick way to do it is t plus equals dt, and my time there has been updated. So I could just run this many times to get new values of t as I go. All right, so far we're not seeing anything too deep here, just using Python as a calculator. Let's do one more step, and then we'll call it good for getting started. So to do this, I want to unlock some of the mathematical power of Python, and we've already seen that we could import the math library, but I'd like to import a little bit more. So from, I want to import a very powerful language called numpy. So now I'm going to import all of numpy, not just part of it. Before we were saying from math, import pi or import sine. Now I want to import all of numpy. But I'm going to do something kind of funny. I'm going to say import numpy, as NP. So numpy gives us a lot of functionality. If you're used to MATLAB, numpy is giving you a lot of the functionality that MATLAB has, or at least similar functionality. It's a nice thing. So it'll give us access to being able to do nice matrix operations, for instance, things like this. So if we import as NP, this means that we won't have to type out numpy every time we're using it. We'll just type out NP. It's a pretty standard convention, and it saves a little bit of time. Okay, so I'll hit enter, import numpy as NP. And you can see that here that's shown up over here, the module numpy has been imported. From here, we can make some nice vectors. So for instance, in Python, both vectors and matrices are called arrays. So let's set up a numpy array. So to do this, I'll say u, that's going to be the name of my vector, is np dot array. So this means I'm using the numpy module, and I'm going to use an array type of variable. And then I can do something like, np array needs an argument, and that argument is put in parentheses. And the argument is, in this case, we'll use some square brackets. So for instance, 4, 5, 6. I can enter this, and now u is this array, 4, 5, 6. If I start another array, such as, let's call it v, and maybe I'll do something like -2, 0, and 1.1. All right, so I've got another array. Then I can take u plus v, and they add as you would expect from vectors. So 4 minus 2 gives us 2, 5 plus 0 is 5, and 6 plus 1.1 is giving us 7.1. So nice, we've got a way to add vectors. If we want to do something, for instance, with matrices, we can do something similar. So I'll say A is equal to np dot array. And then for matrices, I need 2 square brackets. Then let's do something like 1, 2, 3. I'll end those square brackets and put a comma. And then I'll enter the next line, 4, 5, 6. And a little uncreative, 7, 8, 9, and the whole thing. So now if we want to see what A is, it arranges it in this way as looking like a matrix. If we then want to do something like, let's try to square this matrix and see what happens. So if I do A star star 2, you might try to guess what's going to happen here. Square matrix, well, okay, here we've got 1 squared, 4, sorry, we got, 1 squared is 1, 2 squared is 4, 3 squared is 9. Notice this is squaring entry by entry, so it's not doing a linear algebra type of matrix square. It's not multiplying a matrix by itself. It's just squaring each entry, which is not how we normally think about squaring a matrix. If I want to multiply a matrix by another matrix, or in this case by itself, I can use the at symbol. So A at A gives us something like this. And you can double check that this is the matrix square of this matrix A. We can do some other operations, such as a matrix transpose. So if I do A dot T, so what this is doing, the dot is sort of, in this case, it's kind of acting as, the T stands for transpose. Here I'm taking A and I'm acting on it with this transpose. So if I do something like that, I get the transpose of the original matrix A. We can also do something like A, let's maybe clear this, but we still have our variables in memory. If I do something like A at V, at U, I get the matrix vector product of A and U. And notice that numpy doesn't really make a lot of distinction between row vectors and column vectors here. So here it's treating it as the only way, well, I guess it's not the only way it can, but it's treating it as if it's a right multiplication. So it's multiplying it as a column vector without making a strong distinction between a vector or column vector. If I really want to force numpy to think about this to think about a vector as a column vector, I can do something like this. X column, for instance, would be np.array. And then I can enter each individual thing. So for instance, 4, 5, and 6. I can enter each one with its own square braces, and this will force the array to be thought of as a column vector. But often in practice, this isn't too necessary. It's just something good to be aware of. All right. From there, we can let me just mention one last thing about NumPy, which is that it comes equipped with many different functions. So before we were importing sine and cosine from math, but NP has these as well. So for instance, I can do something like say NP dot cosine. So we haven't imported cosine from math, but we imported all of NP. So I can do something like cosine of pi, and we get a nice value for cosine of pi. What if we do, sorry, NP dot sine of pi? Again, we get this floating point round off error. But we have many different functionalities. For instance, we can do something like, if I say t, let's say I want a collection of time values. If I do something like t np dot array, so we can act on many values at once. So I'll put in here a vector. So let's say we'll use so we used pi from math before, but here I'll use the numpy version of pi. So let's see, go pi. So pi over 2, 0, pi over 2, sorry, negative pi over 2 there. And then let's go pi with the np in front of each one, something like this. Then if I type np cosine of t, so t is this whole vector, as we can see, scroll down a little bit, t is this whole array of numbers. If I type cosine of t, then we get numpy is acting on each of these entries individually, which is pretty nice. If we want to take, for instance, the maximum of these, I can do np.max of t, and it shows me that the maximum value there is the pi. That's the largest value in these, and so on. So there are there's a lot of useful functionality. For instance, I can take np.abs to get the absolute value of that vector, and maybe even something like this is a useful operation, np.max. So the maximum absolute value, I can do something like this. Again, 3.14, and so on. So I'll leave you to discover some of the others on the other functionality for these on your own, and sum, and so on. But that's a quick introduction to using some of the functionality of Python, in particular using using NumPy. So thank you for your attention.